Hello and welcome back to Higher Maths, the circle. So we're going to have a look at lesson 2, the general equation of a circle. So we had a look at representing a circle in the previous video. So we have a second formula for the equation of a circle. Let's have a look at it. So if we take the formula from the previous lesson, expand those brackets, collect every term to the left hand side, we could rearrange to get this equation here. So in this equation, which is also given in the exam, as is the equation from yesterday, x squared plus y squared plus 2gx plus 2fy plus c equals 0. Now for this equation, the centre is given by negative g, comma negative f, and the radius is given by g squared plus f squared minus c, all square rooted. Again, if we take that equation from yesterday, expand it, collect all the terms on the left hand side of the equation, and then we will see that this is what we get. So this is just a rewritten version of the equation from yesterday. Again, this is given in the exam. Right, so the radius here is the square root of g squared plus f squared minus c. So if this value is less than 0, this equation will not represent the equation of a circle. Okay, so that's stated there. And that is because we cannot obtain the square root of a negative number. If g squared plus f squared minus c equals 0, so if what's underneath the square root equals 0, then that will have a radius of 0. So it will represent a point rather than a circle. Okay, so there's an example later on that shows that in action. So question number 1 here. Find the radius and centre of the circle with this equation. So I'm just going to rewrite the general equation underneath from the top of the page here. I'm going to match up. So x squared plus y squared, 2gx equals 4x. So g will equal 2. 2fy equals negative 8y. So f will equal negative 4. So my centre is negative 2 comma 4. My radius is given by g squared plus f squared minus c, all square rooted. So I know g, I know f, I know c from the equation here. Substitute in, evaluate, and we'll find the radius is the square root of 13. Okay, so again, just substitution there. Question number 2. Find the radius and centre of the circle with this equation. Well, does it look like that? No, it doesn't at the moment. It doesn't look like x squared plus y squared because we have 2x squared plus 2y squared for the leading term, so we need to divide every single term by 2. So let's do that. Let's compare our coefficients of x and y. So let's compare minus 3x to 2gx, just like we did in the previous question. So g will be negative 3 over 2. 2fy will be 5y, so f will be 5 over 2. Remember, the centre is given by negative g, comma negative f, so the centre will be negative, the negative of negative 3 over 2, so it will be positive 3 over 2, comma negative 5 over 2. And the radius, g squared plus f squared minus c. So squaring negative 3 over 2 squared, squaring 5 over 2 squared, remember top times top, bottom times bottom. So we'll end up with 34 quarters plus a whole, which is 38 quarters, which we can square root to the square root of 38 over the square root of 4, which will be root 38 over 2, because we know the square root of 4 is 2. Okay, again, so get it into this format if it's not in this format. Compare that to the general equation of a circle. Example number 3. Explain why this is not the equation of a circle. So if I see a question like this, guys, I am immediately thinking it's got something to do with this. Okay, so I'm looking at the radius here. That's either going to be 0 or a negative value if it does not represent the equation of a circle. So we need to find g and f first of all. So again, x squared plus y squared plus 2gx plus 2fy plus 29 equals plus c equals 0. So g will be 2, f will be negative 4, my value of c is 29. So let's have a look at g squared plus f squared minus c. That turns out to be negative 9. And as that's less than 0, this is not the equation of a circle, as to find the radius would have to be square root of negative 9, which we cannot do. As we all know, we cannot square root a negative number to obtain a real answer. Okay. Right, question number 4. For which values of k does this represent a circle? Okay, so let's work out g and f first of all. So again, compare this to x squared plus y squared plus 2gx plus 2fy plus c equals 0. So we end up with g equal to negative k, f equal to negative 2, and my value of c is k squared plus k minus 4. So that's a starting point. Remember, to represent a circle, g squared plus f squared minus c must be greater than 0. So remember, to find the radius, we square root that value, so we need to be square rooting a positive real number for a radius to exist. So substitute in. So negative k squared will be k squared. Negative 2 squared will be 4. Subtract all of this. So guys, make sure to remember to subtract all three terms and not just the first term. So I'll have k squared minus k squared, which is 0. I'll have negative of k, so I'll have negative k. And I have 4 subtract negative 4, which is 8. So negative k plus 8, add k to both sides, so k is less than 8, or 8 is greater than k, so k is less than 8. So for any values of k less than 8, so we could substitute in 7, 6, 7.9, any value less than 8, and that would represent a circle. Okay, so as always, have a go at the questions noted on the front of your booklet. So we've just covered lesson number 2, so exercise 14b, and remember the solutions are available here, written solutions, so you can check your answers. So that would normally be probably 2 periods of work for exercise 14b there. There is quite a lot of questions in it.